Imagine you have a satellite, maybe for Earth observation, maybe for communication. Maybe you're building a constellation. And now you're asking yourself, how does this thing get into orbit? The answer is more complicated than most people realize, because it's not just a question of price. It's a question of mass, orbit, reliability, geopolitics, insurance, availability, and sometimes simply whether you're even allowed to put your satellite on a particular rocket. Today, I'll take you through all the relevant launch vehicles on the global market, with prices, payloads, and strategic considerations. And I'll show you why the cheapest rocket isn't always the right one. My name is Servan, and this is Mars Chronicles. Before we start, you should know something about orbits. Before we can compare prices, we need to clarify where the journey is actually going. Because a rocket price, without specifying the target orbit, makes as much sense as a plane ticket price without specifying the destination. Low Earth orbit, or LEO for short, extends from about 200 to 2,000 kilometers above Earth. This is where the ISS, Starlink satellites, and Earth observation satellites orbit. It's the most affordable destination and the largest market. The Sun Synchronous Orbit, SSO, is a special polar orbit in which satellites circle the Earth so that they always pass over each point on the Earth's surface at the same local time of day. Ideal for Earth observation satellites, for example, which need consistent lighting. Technically more challenging to achieve than standard LEO. Then there's the Medium Earth Orbit, or MEO, between 2,000 and 35,800 kilometers in altitude. That's the realm of navigation satellites. GPS, Galileo, GLONASS, Beidou, they all orbit in MEO, typically at around 20,000 kilometers. The reason is simple. From this altitude, a single satellite can see a much larger part of the Earth's surface than just from LEO. Enough to provide precise signals. You need fewer satellites for global coverage than in LEO, but more than in GEO. We'll get back to that in a moment. The compromise between coverage, signal travel time, and constellation size makes MEO the sweet spot for navigation. And recently also for a new generation of broadband constellations that aim to offer lower latency than geostationary systems, but with fewer satellites. Geostationary Transfer Orbit, or GTO, is the intermediate stage on the way to geostationary orbit. So, 35,786 kilometers in altitude, where a satellite rotates with the Earth and appears to remain stationary over the same point on Earth. Communication satellites, weather satellites, but also telecommunications and espionage. That is the most expensive regular destination in the commercial market. And then there are lunar orbits, Mars trajectories, and Lagrange points, but those are niche markets for scientific missions. Why is that important? Because the same rocket has completely different payload capacities depending on the target orbit. A Falcon 9 can carry 22,800 kilograms to LEO, but only 8.3 tons to GTO, almost 3 times less. The price stays the same, but you're getting significantly less performance. In other words, the price per kilo goes up. That's the most important number you need to understand. Cost per kilogram. In spaceflight, efficiency is measured, among other things, by the cost per kilogram of payload to orbit. This number has changed dramatically over the past 20 years. The space shuttle cost around $54,500 per kilogram to LEO. That's not an exaggeration. That was the actual amortized number for average shuttle missions. 1 kilogram to orbit, that costs as much as a good car. Today, you can buy a rideshare ticket from SpaceX. That means a spot on an already planned Falcon 9 mission for around $6,000 per kilogram. For a dedicated mission, meaning a rocket entirely for one customer, the price is around $4,000 per kilogram. That's a reduction by a factor of 10 to 14 compared to the space shuttle. In 20 years. And with Starship? If it works as planned, we're talking about less than $100 per kilogram in the long term. Possibly even significantly lower. That would be a further reduction by a factor of 40. Even with orbital refueling, Starship will beat everything. For the space industry, that's a massive earthquake. Every discussion about rocket prices starts with SpaceX. Because SpaceX is the benchmark, all others have to measure themselves against it. The Falcon 9 is the workhorse. The list price in 2025 was $74 million for a dedicated mission. That comes to about $3,200 per kilogram at full capacity. In practice, many customers buy rideshare spots on already planned Starlink missions for $6,000 per kilogram. But in return, they share the rocket with others. The decisive advantage of the Falcon 9 is not its price, it's its reliability and its cadence. In 2025, SpaceX completed 165 Falcon 9 launches. That means, as a customer, you get an affordable rocket that flies several times a week. Its booster has already flown 30 times. And its operator has well-practiced procedures. Turnaround in 13 days? That is operational efficiency at a level that no other company in the world even comes close to achieving, even if they claim they could. The Falcon Heavy is 3 Falcon 9s, literally, because it consists of 3 coupled Falcon 9 core stages. List price around $90 million in the partially reusable version, 54,400 kilograms to LEO. That comes to about $1,700 per kilogram. For heavy GTO missions or missions with high energy requirements, the most efficient solution on the market. Short break. If you're already getting something out of this video, then hit the thanks button if you have it. If not, a like, a subscription, or a comment also help the channel a lot. The algorithm will decide in the next few minutes whether to spread this video further or not. And you have a say in that. Thank you. And now let's continue. ULA, or the United Launch Alliance, a joint venture between Boeing and Lockheed Martin, was for years the only serious American provider besides SpaceX. With the Vulcan Centaur, ULA has built a successor to the Atlas V and Delta IV Heavy. The Vulcan costs around $100 to $140 million per launch. Payload to LEO is 27,200 kilograms, more than the Falcon 9. That comes to about $4,000 per kilogram. So, more expensive than SpaceX for a similar payload. You're probably asking yourself the following question right now. Why do they even still exist? That's an excellent question. 1. National security. The American government wants at least 2 independent access options to critical orbits. ULA has received a $5.3 billion contract for 19 missions under the National Security Space Launch Program, or NSSL. That is institutionalized competition. Not because ULA is cheaper, but because monopolies in national security are dangerous. However, there have been repeated problems with the solid rocket boosters during recent launches. Now the Space Force is keeping a very close eye on them. 2. And that's how the ULA argues, with specific mission profiles. For certain high-energy missions to distant orbits. A minimal niche of just a few launches per decade. Besides, the Falcon Heavy can do all of that as well. Most of it can even be handled by the Falcon 9, and now there's also Blue Origin's New Glenn. But more on that later. The Ariane 6 is Europe's answer to a problem that has shifted. It is Europe's sovereign launcher. Development costs 4 to 5 billion euros. List price $80 to $120 million, depending on the configuration. Payload to LEO in the larger configuration, 21,600 kilograms. The problem? The Ariane 6 was developed to replace the Ariane 5 and to be competitive with the Falcon 9. But the development took so long that by the first launch in 2024, the Falcon 9, which it was supposed to compete against, was already much cheaper and more reliable than planned. A European space executive said, Ariane 6 is essentially the answer to Falcon 9 from 10 years ago. A classic case of running to where the ball is instead of where it will be. The rocket is a one-way trip, so no reusable stages. In a world where reusability is becoming the standard, that's a structural handicap. So why would anyone buy the Ariane 6 at all? European institutional customers, like ESA, European authorities, and European satellite operators have an interest in maintaining European access for political and strategic reasons. It's similar to what the Americans do as well. That might seem like an irrational decision. But what you're seeing here is sovereignty as a product. The New Glenn, Blue Origin's first heavy-lift rocket, flew for the first time in 2024 and has already completed several successful launches, including NASA's Escapade Mars mission. The latest mission on April 19, where they achieved the first booster reuse, seemed to go perfectly at first glance. The booster named Never Tell Me the Odds landed for the second time after a successful mission on the drone ship Jacqueline. One of the two BE-3U upper stage engines did not provide enough thrust during the second ignition. As a result, the satellite ended up in too low an orbit and deorbited a few hours after launch. The mission was ensured. However, this is a severe setback for Blue Origin. Even though setbacks are part of the process, they hurt and damage the reputation, especially when it affects the customer's figures. The customer was the Bluebird satellite from ESD Space Mobile. They will also be more than just peripherally affected, because they are currently trying to get their 50 to 80 satellites into orbit as quickly as possible. But what they got instead is a lost satellite, and one of the rockets they use is now grounded. Share your thoughts in the comments. The list price of the New Glenn is between $60 and $90 million. Payload to LEO is around 45,000 kilograms in the standard configuration. That makes the New Glenn extremely competitive on paper. Almost twice as much payload as the Falcon 9 at a comparable price, under $2,000 per kilogram at full capacity. The first stage is reusable and lands on a ship in the ocean, similar to the Falcon 9. The second stage is expendable. The uncertainty around New Glenn is the same as with any new launcher. Reliability takes time. SpaceX had over 300 Falcon 9 launches behind it before the rocket gained the trust of the most demanding customers. New Glenn has only just begun. For customers who don't need to rely on a proven rocket, who are pioneers or simply prioritize lower prices, the proven rocket is for customers. With critical missions and tight schedules, the Falcon 9 remains the safer choice for now. But to speed up this process of building trust, Blue Origin poached the former CEO of ULA and tasked him with securing these lucrative institutional contracts. And then there's the New Glenn 9x4, a planned variant with 9 engines in the first stage instead of 7. Significantly more thrust, significantly more payload. No official price so far. Blue Origin is being very reserved in their communication here. Japan has developed a new rocket, the H3. Target price is around $50 million per launch. Payload to LEO, 16,500 kili. That would be competitive if the first launch in 2023 hadn't failed. That was followed by 5 successful missions, and the last one in December 2025 also failed. Japan is building long-term independent access to space for national and commercial missions. India has solid medium-class rockets in the GSLV and LVM-3, which are increasingly being marketed commercially. OneWeb, for example, has booked several launches. Price around $60 to $80 million. And the payload in LEO is around 8 tons. Now we're entering a segment that has exploded in recent years. The launch vehicles for small and very small satellites. Rocket Lab's Electron is the market leader in this class. Its price is between $7.5 and $8 million. It delivers 300 kilograms to LEO. That comes to $25,000 per kilogram. So that's 8 times more expensive than Falcon 9 rideshare missions. Why would anyone buy the Electron? Because they want control. With rideshare on Falcon 9, SpaceX determines the orbital inclinations and launch dates. Anyone who wants to put their satellite into a very specific sun-synchronous orbit at a certain time knows that a delayed or incorrectly placed mission can sometimes cost more than the price difference. That is the core of the small launcher market. Not price per kilogram, but flexibility and control. ESA Aerospace from Munich attempted their first Spectrum launch in March 2025 and fell into the sea shortly after liftoff. A valve opened unexpectedly, and the vehicle lost attitude control. The second launch is set for later this year. Spectrum carries about 1,000 kilograms into SSO at a target price of 10,000 euros per kilogram, which would mean a launch price of around 10 million euros. Their second launch attempt is imminent. RFR-1 from Rocket Factory Augsburg has also not yet flown to orbit. The vehicle exploded during the static fire test on the Shetland Islands in Scotland. August 2024. Nevertheless, ESA included RFA in their European Launcher Challenge, together with ESAR and 3 other European companies. A total of almost 1 billion euros in funding. PLD Space from Elche, Spain, is building the Miura 5, which can carry about 300 kilograms of payload into SSO. The first orbital launch is still planned for 2026. The company has just raised $209 million, including $5 million from Mitsubishi Electric. Spain has allocated over 169 million euros of ESA funds for PLD. That's genuine government support. What all 3 European launches have in common is that they haven't flown regularly yet. That's the key point, which we'll revisit soon. Now we have to take a look into the future. Relativity Space has discontinued its Terran 1 launch vehicle. It never successfully reached orbit, and the company is now working on the fully reusable Terran R. It is supposed to deliver around 20 tons to low Earth orbit. That puts it in the same category as the Falcon 9. But if it is supposed to be fully reusable, then it will probably have to be much larger as well. I'm curious to see what approach they'll take for recovering the upper stage. A few more words about their 3D printing promise. Their initial goal was to build a rocket entirely using 3D printers. The idea was to complete years of manufacturing in just weeks. They have moved away from that a bit. It turns out that certain things can actually be made better with traditional manufacturing techniques. They don't have an official launch date or confirmed launch prices. Rocket Lab's Neutron is the most ambitious bet in this field. 13,000 kilograms to LEO, rocket booster reusability. What's special here is that the Neutron has an upper stage that is not reusable. This is located inside the payload fairing at the top. And unlike other rockets that jettison this cover, these are fixed in place and close again after the upper stage is released. Their target price is between $50 and $55 million. That would be around $4,000 per kilogram. So, on par with the Falcon 9 but with a smaller rocket. The first launch was originally scheduled for mid-2025, then for the end of 2025. Now it's mid-2026. The delays are adding up. Rocket Lab is still largely on schedule for such a complex development despite everything. The launch pad on Wallops Island in Virginia is ready. The first test launch will show whether the theoretical numbers hold up. Neutron is strategically interesting because Rocket Lab already has a functioning, profitable business with Electron. They don't need investor stories. They need a real rocket. That sets them apart from startups that rely solely on future revenue. Apart from that, they have a completely different line of business that makes them very solid. With them, you can have a satellite designed, built, launched, and operated. That seems to be a very attractive business model. Now we have to talk about Starship. Starship is fully reusable. Booster and upper stage. They're not quite there yet, but it can only be a matter of years. But even without reusing the upper stage, the Starship system can be used. And every launch is used to perfect reusability. With that, I would say that Starship will come to market earlier than many people can imagine. It is supposed to deliver at least 100 tons to low Earth orbit at least once in its reusable configuration. Up to 250 tons if you forgo the return. For comparison, the entire International Space Station weighs around 420 tons. With orbital refueling, Starship is supposed to be able to deliver the mentioned 100 tons to the surface of the Moon and Mars, later versions even more. Elon Musk is talking about a long-term launch price of under $10 million. In the more realistic near future, meaning in the next few years, with partial reuse and increasing cadence, we're talking about $100 to $200 per kilogram. For comparison, the space shuttle was $54,500 per kilogram. If these numbers are even remotely achieved, Starship will fundamentally change the entire spaceflight sector. Satellites that can't be built today because of the launch price will suddenly become economically viable. Missions to the lunar surface, to asteroids, or to Mars will become affordable for private actors. The $10 billion James Webb Space Telescope had to be folded up because Ariane 5 wasn't big enough. It fits inside Starship unfolded. Just imagine what will be possible with that. This isn't advertising material. These are the physical consequences of a very, very large, very cheap, fully reusable rocket. By the way, if you're as fascinated by Starship as I am, we've got something for you. In the next few days, these strictly limited Starship models will be available in our shop. Some of them have already been reserved. If you want, you can reserve one by email. Some are already gone. We used the Prusa-Core one for production. It's excellent for small batch manufacturing. And for those who can wait a bit longer, SLS is coming next. Stay tuned. Links to the printer and the model are in the description below. Let's get back to Starship. Starship is not commercially operational yet. The first commercial missions will launch in 2027. One of the first payloads, the Superbird 9 from a Japanese provider, is being built by Airbus Defence and Space in Toulouse, France. Reliability must first be proven through launches, not promises. That applies to all launch providers. And Starship's next launch, that is, Flight 12, could take place as early as the beginning of May. We still need to discuss Russia and China. Two markets that you usually can't use anyway. We'll take a look at them anyway. Soyuz 2 historically costs around $4,850 million. It can carry about 8.2 tons to LEO. The cost effectiveness before the war was already decent. After February 2020, it was no longer available to Western customers, neither legally nor politically. Russia's Proton M was the heavy lift rocket for GTO missions and is being phased out because it no longer has a relevant market position. In other words, nobody needs it. China has a whole family of Long March rockets, from small to super heavy variants. The Long March 3B for GTO missions costs around $70 million. Cheaper than Ariane 6, more comparable to the Falcon 9. Payload to GTO is 5,500 kilo. The problem for Western customers? Most Western satellites contain American components or are built for American or allied institutions. And ITAR, the International Traffic in Arms Regulations, in many cases prohibits launches on Chinese or Russian launch vehicles. That's American law, and you have to comply with it if you use these components. It launched over 90 times in 2025. That's enormous and shows the capacity. But this market is simply not accessible to most of the commercial Western satellite industry. Now comes the part that's not included in any simple price comparison. Namely, the strategic considerations behind the decision of which launcher to choose at the end of the day. Orbit first. Before you even consider a provider, you define the mission profile. Which inclination, meaning the tilt relative to the equator, what altitude, what local time in SSO, what transfer orbit requirements, and so on. That immediately rules out a large portion of the available rockets. Dedicated or rideshare. Rideshare is cheaper per kilogram, but you fly into the main customer's orbit. Anyone who needs to hit their exact orbit precisely pays for a dedicated mission. Anyone who is flexible or has their own engine can save significantly with rideshare. Reliability costs more than the sticker price. If your satellite costs $50 million and is lost on a cheap but unproven launcher, the $5 million discount on the launcher wasn't a good deal. Insurance premiums reflect that. A launch on the Falcon 9 is cheaper to insure than a launch on a launcher with only 3 launches. Dann die geopolitische Exposition. After 2022, everyone who relied on Soyuz learned Launch capacity must not be a single point of failure. For critical missions, national security, and large constellations, you either need several qualified providers or you consciously accept the risk. Timing and availability. Falcon 9 flies several times a week. New Glenn monthly. Neutron has not flown yet. If your satellite has a window-dependent launch date, for example, for a Neutron has not been found, Neutron has not been found yet. Not Neutron capacity at the right time is more crucial than the price. Contractual flexibility. SpaceX is known for relatively rigid contract terms, especially for very small customers. Smaller providers are much more adaptable in this regard. For experimental missions or research institutions that frequently change their requirements, this can be relevant. Sovereignty as a product. That sounds abstract, but European institutions, Japanese authorities, Indian government agencies, and even the Americans, all of them have a legitimate interest in not being solely dependent on an American company. That's not irrational at all. It's geopolitical risk management. And that's why there's Ariane 6H3 and the European Launcher Challenge, even though Falcon 9 is cheaper. And what does that mean now? We're currently living in the brief historical moment when the cost of access to space is dropping dramatically, but not yet evenly and not yet reliably with all providers at the same time. SpaceX has a structural and technical lead. With over 600 launches of experience, reusable boosters with 34 or more flights, and a weekly cadence, that gap can't be closed in 2 or 3 years. At the same time, having a market with a provider who controls 2/3 of global orbital launches is not a healthy situation for the overall industry. That explains why many states and private investors continue to invest in competitors. Not because they believe they can beat SpaceX, but because they want to prevent a monopoly by any means necessary. And that's a good thing. There's nothing worse than monopolies. And Starship, if it works, doesn't just change the question for satellite operators. It changes it for lunar missions, for science telescopes, for industrial manufacturing in orbit, for everything we haven't done so far because it was too expensive. The space shuttle cost $54,500 per kilogram. Falcon 9 is around 3,000 to 4,000. Starship aims for under 100, and it's coming fast. The world isn't ready yet. Space is becoming affordable. For whom and under what conditions, that will be decided in the next decade. If you want to dive deeper into individual rockets or the question of European sovereignty, feel free to write it in the comments. I read every single one of them. A big thank you goes to Pusa. Without her support, this channel would look completely different. My name is Servan, and this was Mars Chronicles. Thank you for tuning in. Spera ad astra.
Prioritize, 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 prioritize.
Prioritize, prioritize, prioritize. I hope I won't be able to say that word anymore. SSO orbit. SSO orbit. It's called SSO.